Okay, folks, looking at our DMR. This is your DMR from yesterday. Read each answer choice below and choose the best answer to the question in the story problem below. Josiah and Cameron are playing with Legos. Cameron built a fort using 843 Legos. Josiah used 28 more Legos than Cameron. How many Legos did Josiah use for his fort? Cameron used 843. Josiah used 843 plus 28 more. 8 plus 3 is 11. Carry our 10, put down our ones. 1 10 plus 4 tens is 5 tens, plus 2 tens is 7 tens. 8 hundreds plus no hundreds is 8 hundreds. So this question is about Josiah, and Josiah used 871 Legos for his fort. Josiah and Cameron did not both use 871, only Josiah did. Questions, concerns, comments? All right. Next up, how many unit fractions of the bottom model will it take to equal the top model? Our models line up right there, and we need 1, 2, 3, 4, 5, 6, 7, 8 1/10 pieces until it is the same size as 4/5. So we need 8 of them. Questions on that? Alrighty. Choose the comparison sentence that best matches this model. I have 1, 2, 3, 4, 5, 6 pieces. This is 2, 6. On the bottom, I have 1, 2, 3, 4, 5 pieces. This is 2/5. I am dealing with 2 6 and 2/5. I can see that 2/5 is longer. It goes all the way out here. 2 6 stops all the way right here. So 2 6 is less than 2/5. This is the best answer. 8 and G.
So when I chose the one above that answer, I got confused because I thought we were still doing that part where it's the bigger one than the size. But when you did, I understand it because you you put the side. Never mind.
I'm glad that you got that correction made. You guys have the visuals right in front of you, so you guys can see the visuals to show you. You don't even really have to think about what the rules are when you've got a picture right in front of you. Clearly 2/5 is longer. Okay. All right, next one, it says there are 3 answers. So when it says all, it's talking about 3. That's a hint for you. Test smarter, not harder. Choose all that are true about this equation. 893 subtract 678. One of the statements is about the difference, so I need to know what the difference is in order to know if that statement is true. So 893 subtract 678. 3 subtract 8 is impossible, so I have to regroup. I'm going to add 10 because I borrowed a 10 from here. 3 and 10 is 13. 13 ones, subtract 8 ones, 13, 12, 11, 10, 9, 8, 7, 6, 5. 8 tens subtract 7 tens is 110. 800 subtract 600 is 200. So my answer is 215. So yes, the difference is 215. That's one of my 3 answers. The answer to this equation is called the difference. That is also true. Answers to subtraction problems are called differences. You can use addition to check the accuracy of this answer. That is also true. I can take my answer of 215, add it to my smaller subtrahend of 678, and see if it equals 893. 5 plus 8 is 13. Carry my 10, put down my 3 ones. 110 plus 110 plus 7 tens is 9 tens. 200s plus 600s is 800. So yes, 893 is the same as 893. The answer is more than 1,000. No, the answer is 215. That is less than 1,000. The numbers in this problem can be reversed because of the commutative property. No, you cannot reverse numbers in subtraction. 678 subtract 893 would give you a debt, which is negative, which is not possible. Okay, William, a question.
It's not a question, but the fourth answer would be correct because it only says 3 points, and 893 is the main number. 1,000 is more than 893.
So when I know that these 3 are correct, I'm just checking to see if these others are correct or not, because I know I already have 3. Great point. All right, next up. Compute to find the answer. 90 divided by 9. I know that 90 is a 10, and I can count by 10 9 times, so my missing number is 10. 90 divided by 9 is 10. You should have typed 10. 10, 20, 30, 40, 50, 60, 70, 80, 90. That's 9 of them, and I got to 90. Okay? Questions on that one? Okay. Let's take a look at our final one, number 7. It says choose the fraction that matches this model. My numerator, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. My denominator has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. This fraction is called 9/10. Any questions on that? All right, folks, tomorrow is your test, your DMR quiz. Get ready, get ready, get ready for your quiz. All right, folks, let's switch gears. We are going to take a look at our equivalent fractions. Here is your goal for the day.
Third grade. Today we're continuing our recognizing and generating simple equivalent fractions. And we're also going to be working on explaining why the fractions are equivalent. So again, today, recognizing simple equivalent fractions and explain why 2 fractions are equivalent. We will use vocabulary such as numerator, denominator, equivalent, fraction models, and equal parts.
All right, there's our vocab. Let's get to it. So we are going to complete this warm-up together on Seesaw. You'll need to click your activities bulb to refresh your feed. That will bring you up to an activity called Equivalent Fractions Number Line Edition. Go ahead and select that add response. We've already looked at the success criteria. We're getting ready to complete the warm-up, okay? We're going to do the top section of the warm-up together. Then I'm going to stick you into some breakout rooms to complete the rest of that warm-up. And when you get back, we will check your answers with me, okay? All right. So this says the top number line shows a point at 1/4. Sure enough, there it does. There's a point, there's 1/4. Write the fraction for each of the points labeled A, B, C, D, E, and F. Which of these fractions shows the same distance as from 0 as 1/4? Okay, so you have 2 things to do. First thing you're going to do is you are going to write the fraction for each of the points. The second thing that you are going to do is you are going to answer the question, which fraction is the same distance from 0 as 1/4? Let's take a look at how to do these together. Take a look at this first number line. My denominator is a 4, so I already know that A is going to have a 4 in the denominator. It's on the same number line. That's one hint. If I was completely lost and that was still confusing, then I can do what I always do and count my hops. There are 1, 2, 3, 4 hops on this number line. So sure enough, my denominator remains a 4. My numerator happens after 2 hops. 1, 2. So this fraction is 2/4. 2/4. Okay? In your breakout rooms, you are going to find out the name of the fraction for B, C, D, E, and F. There are not denominators here. So you're going to have to count the hops, the spaces on the number line to come up with those fractions, just like we did in our DMR. Then when you have all the names of the fractions, which one is in the same place as 1/4? Hint, 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 hint. Okay. So you're going to solve slide 2 with your breakout room. I'll give you 2 minutes. Go. Here are the correct answers that your group should have found. B is at 2/3. 1, 2 spaces, 3 spaces on the whole number line. C is at 1/2. There are 2 hops on the whole number line. D, there are 8 hops on the whole number line. 1, 2, 3, 4, 5, 6, 7, 8. D is at 2 eighths, 2 of them. E is at 4/8, 4 of the hops. F is at 4/6. The question was, which has the same distance from 0 to 1/4? Here's 1/4. Straight down is 2/8. So this is the same distance. So 1/4 is equivalent to 2/8. Okay. This was a warm-up. If you did not get it all done, that is fine. We are getting ready to move on. All right. Slide 3. This is an example that you're getting ready to see in the video. I'm going to play the video for us, and you will be able to see this information. They are going to be working with cattle traveling on a ranch, on a trail. Okay, so they're moving down a 1-mile trail, and they are going to stop for water at specific distances. We are going to find distances that are the same. Please watch and think.
How can you use number lines to find equivalent fractions? Think about this question during the lesson. The Circle W Ranch 1-mile trail has water for cattle at each 1/4 mile mark. The Big T Ranch 1-mile trail has water for cattle at the 1/2 mile mark. What fractions name the points on the trails where there is water for cattle at the same distance from the start of each trail? Let's find out. What is the same about the drawings of the 2 trails?
Okay, what do we see that is the same about these drawings? What do we notice that is exactly the same as the drawings? Q.
Both of the pictures have plants and trees.
They do. They're both got plants and trees going on. Let's think about the math. What do we notice that is the same about the math? Steve Rogers?
They're both
They are both equal size lines. They both start right there. They both stop right here. So they are the same distance of line. Very good. Continue on.
Both the same length, and they both represent 1 mile. What is different about the drawings of the two trails?
Let's frame our thinking for math. What is different here? What is not the same? Aiden G.
that there's more animals on one part and it's less animals on the other part.
True. The top for circle W has more animals. Big T has less animals. What else is different here? Christopher.
Have the water. The top one has 4 and the bottom one has just 1.
Yes, our top one, Circle W Ranch, has 4 watering locations. The Big T Ranch has 1 watering location. Okay, we can see that this splits the number line into fourths and into halves. Okay, so our fractions, our unit fractions are different.
The drawing for the Circle W Ranch Trail is divided into 4 equal parts. The drawing for the Big T Ranch Trail is divided into 2 equal parts. You can use number lines to find the fractions. What fraction is missing on the number line?
What is missing here?
Select your answer.
1/4, 1/3, 1/2, 2 halves. What is missing? What goes here on this question mark? 1, 2. What's missing there, William?
1/2.
1/2. We have 1 hop. There are 2 hops on the whole number line. So 1/2 is correct. We are missing 1/2. Excellent.
Equivalent fractions are different names for the same point on a number line. 2/4 and 1/2 name the same part of the whole. So 2/4 equals 1/2.
I want to talk about this. On some of your, actually on most of your work, you guys were telling me what was the same as 1 whole. That's not the question. The question is 2/4. So I look at 2/4. And then I look at what is in the exact same place. And that is 1/2. A lot of you were telling me on your work that 2/4 is equal to 1 whole. And I don't know how you think that, because if we were to say 2/4 is equal to 1 whole, which first of all is wrong, we would be saying that this size is equal to this size. And I know that y'all have eyeballs and can see that that's not true. I don't know what our fascination is with 1 whole, but we are done with it. We are looking at 2 fractions. That means 2 smaller parts that are the same size.
How do you know that 1/2 and 2/4 are both names for the same location on the number lines? They name the same points on the number lines.
Okay, we're going to try it together on Seesaw. So these problems have been put for us on Seesaw. If you get stuck today or are frustrated with your work, you can come right back here and observe this example. You can also watch this video again. It is right here for you as an aid, okay? Let's go to slide 4. It says with your teacher. On slide 4, it says Ian paints 6/8 of a fence. Anna paints 3/4 of another fence of equal size and length. Draw a number line to show that Ian and Anna have painted the same amount of fence. So we have to do two things. We have to do our number lines, which we've already done for you, and we have to show that they painted the same amount. Okay, so let's go ahead and get ready here. I highlighted Ian in purple, so I'm going to change Ian's dot to purple. And I know that Ian worked with 8s, so I'm going to work on the number line that has 8s. And I'll even put an I right here for Ian. 6 8s, 1 8, 2 8s, 3 8s, 4 8s, 5 8s, 6 8s. There's Ian. Boom, right there. Anna, I highlighted in green, so I will change it to green so that it's easy for my brain to see the difference. Anna painted 3/4, 0, 1/4, 2/4, 3/4. Boom. I can very clearly see that these are in the same place. They line up at the exact same position. So this is proof, oops, that 6 8s is equal to 3/4. I'll give you a moment to get caught up on that. As you're catching up, please let me know what questions I can answer. Okay. So this is how we know they are equivalent fractions. They are the same distance, starting at 0 and stopping here. The fractions have different names, but they are the same amount of the whole. Let's take a look at slide 5. Slide 5 says, complete the number line to show that 2 6 and 1/3 are equivalent fractions. So we're going to show 2 6 and we're going to show 1/3. Let's drag our red dot to 2 6. Our blue dot goes on 1/3. 2 6 and 1/3 line up in the exact same place. They start at 0, they stop there. So that is proof that 2 6 is equal to 1/3. Let's take a look at problem 2.
Yes.
Okay, good. You're still there. It's weird, guys. You're all just completely black screens. That's all I got over here. So I'm glad you're still here with me. Thank you. All right, slide 2, or I apologize, question 2. Question 2 says, Sheila makes a number line to see if 4 6 and 4 8s are equivalent. She discovers that these fractions are not equivalent. How does she know? Okay, so let's figure it out. Let's take our yellow dot and put it on 4 6. Our purple dot goes on 4 8s. They both have a numerator of 4. But that denominator says that the part size is different. we can see that 4/8 is not equivalent to 4/6. Our question says, how does Sheila know? So we have to answer that question. 4/8 is not equivalent to 4/6 because 4/6 is greater than 4/8. 4/6 is a longer section of that number line than 4/8 is. Questions on that? Okay. Let's take a look at slide 6. Slide 6 says, with your teacher, use the website to build the fractions to see if they are equivalent. I want to talk about this direction right here. On independent work, I am getting a lot of people that are not doing it. It says use the website to build the fractions, so I need to see the fractions built. I cannot award points to you. Let me rephrase that. You cannot earn points for work that you don't do. Part of what my job is to make sure that you understand how to build fraction models. If you don't show me that, you don't earn credit for it. I don't have proof that you know how. Okay? So you need to look very carefully at the directions. This isn't if you need it or if it helps you or if you like to. It says use the website. Done. Do it. Use it. End of conversation. Okay? We need to start showing our work. I have quite a few people who have stopped doing that. You have to show your work if it tells you to show your work. Okay? Use the website to build the fractions to see if they are equivalent. So we're going to take a look. Which fraction is not equivalent to 3/6? Okay? So I'm going to open up my website and I'm going to show you that I have to do the same thing as you do. I have to go back and forth between the tabs to see the fractions. And yes, it takes time. And yes, it's annoying, but yes, I have to do it. Okay? So we have 3/6. That's the first fraction that we have to build. Open up your website and please
It
build
is blocked.
3/6. I will turn it off. Thank you. And remove. There you go. Good to go. Go to build 3/6, 1/6, 2/6, 3/6. Please get that done. Build 3/6. Okay. Then we see that we're supposed to look at 1/2. Let's put 1/2. Ugh, that's the same size. The question is which one is not the same. So now I have to do 2/4. See how I did 1/2? Now I'm doing 2/4. Let's grab 2 1/4 pieces. 1 1/4, 2 1/4. Ah, that's the same too. It's equivalent.
Because they're equal numbers.
Next up, it says 2/3. Let's go grab 2/3. Here's 1/3. Here's 2/3. Dun, 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 dun. That is not equivalent. It is longer than the other pieces. I have found my answer. Okay, so now I'm going to take a screenshot. Copy it. I'm going to put it on my work. Boom, as proof of my answer. So which one is not equivalent to 3/6? 2/3. Okay, so we know that 2/3 is not equivalent to 3/6 because 2/3 is a greater fraction than 3/6. Yes, Aiden Hampton.
I joined late, so what are we doing?
Welcome. We are on a math assignment that is titled Equivalent Fractions Number Line Addition. It's right at the top of your seesaw. You'll just need to join in where we are, and you'll have to watch the video recording to catch up later, okay? All right, let's switch to problem 15. Problem 15 says, which fraction is equivalent to 4/8? Here's 4/8. And I've got to build because it says use the website. So that's what we're going to do. I'm going to erase my old work. It asked me about 4/8. Grab 4 1/8 pieces. 2 1/8, 3 1/8, 4 1/8. Okay. We are asked about 3/8. Let's put 3/8 underneath. 1/8, 2/8, 3/8. Well, that's not the same size. Our question is which fraction is equivalent? So we got to keep going. Next one is 2/4. Let's build 2/4. 1 1/4, 2 1/4. Can it be? It can. 2/4 is the same as 4/8. So we are going to take a picture of that. We are going to upload it into our seesaw assignment as proof. So which fraction is the same size? 2/4. 2/4 is equivalent to 4/8 because they are the same total size or total length. Notice I don't just say because they are the same. That could be about the same color. It could be about the same website. I need to use math vocabulary. They are the same total length, okay? Slides 7 and 8 are breakout room work. We're going to go about 5 minutes over. I'm going to send you into a breakout room. You have 3 problems to solve. You're going to solve slide 7. You're going to solve 2 problems on slide 8. Okay, slide 7 and slide 8 with your breakout rooms. When you get back, we will check our answers. And go. Okay, if you completed your work correctly, this is what you should have found. How can you tell just by looking at the fractions that 2/4 and 3/4 are not equivalent? Because they have the same denominator, but 3/4 has a greater numerator. Okay, we can tell just by looking at them that when the denominator is the same, the numerator is going to tell us the number of parts. Slide 8, the directions say write 2 fractions that name the same location on the number line. The first location was given to you, 3/6. 3/6 is in the same location as 2/4. 3/6 is equal to 2/4 is what you should have found. We have 6/8 and we have 3/4. 6/8 is equal to 3/4 because they are in the same location on the number line. Any questions about those two? Okay. You are going to be completing these number line problems as your independent work today. Your independent work begins on slide 10 and continues through slide 14. Okay? Slide 10, 11, and 12 are looking at number lines with equivalent fractions. Slide 13 is asking you to build number lines and answer a question about their equivalence. Slide 14, as always, using your math vocabulary. How do you know you met those goals? This is your independent assignment for the day.